Video to show you how to convert a letter into ASCII and then from ASCII into its binary value. So the basis for all of our ASCII to binary conversions is the understanding that there's something out there called ASCII conversion table. Okay, so here we have the ASCII conversion table, and what you'll notice, it has symbols and letters in this very third column. And then you'll notice that it also attributes that symbol, letter, character to an ASCII value. So we already know from a reference point that a capital A has a value 65 and a lowercase a has a value of 97. So if we're then asked to convert the letter H, which is a lowercase, into a binary value, the first thing we need to know is it's ASCII reference. So it's ASCII reference. We know that little a, as I said, is 97. So if we count up and we go A, D, E, F, G, and H, so we know A is 97, B will be 98, C will be 99, D will be 100, E will be 101, F will be 102, G will be 103, and H hopefully will be 104. So we already know that our ASCII code or ASCII value is 104. Now what we need to do is the same as we did before. It's 104 is obviously a decimal value. So we need to convert that decimal now into binary. So how do we do that? Once again, we go back to our binary conversion, understanding of binary number conversion, and the understanding that the right-hand column has the smallest value, which is 1, and every time we move one spot to the left, the value of that column doubles. So 1, double 1 is 2, double 2 is 4, etc. So to get the value 104, what we need to do is we need to make sure that any column that has a 1 underneath it, when we add its value together, totals no greater or no less than 104. So we run down that value row and we look for the number that's the largest number that's equal to or lower than 104. 128 is too big, but 64 is perfect. What we then do is we say, okay, we're going to have one lot of 64. And at this point in time, we follow the same process that we do when we're doing any decimal to binary conversion. So we say we've started with 104, we've just taken out 64, so we've still got to find another 40. Another 40 units. So we work now with 40. So we're looking for the number that's largest, the largest number that's less than or equal to 40, and of course that's 32. So now 40 minus 32, we've now got 8, so we're trying to find 8. So the next value that's largest value that's less than or equal to 8 is of course 8 itself. Now what we need to do is then fill the remainder of these columns with 0, just so we can have everything line up in terms of its place value. Minus 8 equals 0. So now if we do the calculation, we say this value, so 64 plus 32 plus, no 16, 8. Hopefully it gives us 104. Let's just check. 64, 32 and 8. Of course that's correct. So in answer to our question, H in ASCII is 104, and 104 base 10 as a binary equals 1, 1, 0, 1, 3. Base 2, of course it's base 2 because it's binary. I'm going to format this font and not make that. So 1, 1, 0, 1, 0, 0, 0, that's correct. And that's how to convert a letter or a symbol into ASCII and from ASCII then into binary.